Here we are in As You Learn, and we're going to be looking at SPSS and figuring out how to estimate the frequencies that you need for a Turnbull estimator. So for this practice data, we're going to look at estimating benefits of a red drum stocking program in South Carolina. This is from a project that I worked on 10 or so years ago, and the red drum is a game fish in South Carolina, and they've been stocking that thing for a while now. And we did a benefit cost analysis of the stocking program. And there's the fish. I hear it's fun to catch. And they've been stocking it in these locations. And the data we're going to be using is from an intercept survey at north of Disto River and Charleston Harbor. And this presentation just describes a little bit about what was done for a larger project. There's the fish again. This presentation describes why you might want to stock the fish, and then some background on the study itself and methods estimating economic benefits. For this part of the study, we did a statewide mail survey of everyone who had a saltwater fishing license. And presented a contingent evaluation method question to people who responded, or to people we surveyed, and the bid amount ranged from $5 to $20 to $30 to $50. The payment vehicle was a tax credit checkoff on the survey respondents' state income tax deduction or tax return. And in estimating benefits, we talked about the survey response rate. One thing that we'll look at is how to handle hypothetical bias. And we asked a certainty follow-up question, and we recoded the wills to pay responses if someone was not certain about their answer. And here is the crosstabs that we did for the statewide mail survey. And these are just the hypothetical bias corrected values or percentages of people who are willing to pay the different bid amounts. We split the sample into people who do not target red drum when they go fishing, which means they don't try to catch the fish, and people who do target red drum. So as the bid goes from $5 to $50, the number of people who say they would donate that amount to the stocking program falls from 37% to 7% for people who don't target the fish. For people who do target the fish, it falls from 62% to 25% as the bid goes from 5 to 50. And there is the downward sloping demand curve, and these bars look like the geometric areas underneath the demand curve that we use for the Turnbull estimator. Okay, so let's take a look at the survey itself. And this is what was sent out to people who had a saltwater fishing license, and in the case of the data that we're looking at, these are people who were intercepted while they were fishing at the North Edisto River or Charleston Harbor. So there's a lot of preliminary questions. And then here's a contingent evaluation scenario that's presented here in section B. And then on the next page, question B1 reads, would you personally be willing to make an annual involuntary contribution of $50 to a special fund to support a South Carolina red drum stocking program? And this $50, this is where the other bid amounts were randomly assigned to other people. So if someone says yes, then they go to question B2, which is the certainty question. So then we asked on a scale of 1 to 10, where 1 is very uncertain and 10 is very certain, how certain are you that you would actually contribute $50 per year to a special fund to help support a red drum stocking program? So if they might say yes, they're very certain, or 9, 8, 7. The cutoff that we're using in this study and what has been found in the economic literature to match up hypothetical and real payments pretty well is this cutoff at 7. If someone says they're willing to pay, if they're certain at the level 7 or above, then sometimes you conclude that there's no hypothetical bias present for those. But if they're certain at the level 6 and below, then we say that those people have hypothetical bias. So here's the data. This is Charleston Harbor, CH. There's 317 observations in there. So this is on As You Learn, so you can download it yourself. I'm going to go ahead and go to SPSS. And here's SPSS right after I open the program. So now if I click on data, if I click on file and import data, that Charleston Harbor, North Edisto River data is in an Excel spreadsheet. So I'm going to click on Excel. And the open data window pops up. So I've also saved the data on my desktop. So I'm going to open that file. And it tells me it's open in another application. So I'm going to close that. Now let's try again. File, import data, Excel, open. There we go. So the read Excel file pops up and the boxes are checked. Read variable names from the first row of data. So every data set you have is going to have the first row of data in the Excel spreadsheet is going to be the labels. So we're going to leave that checked. And the percentage, I have a student coming in 10 minutes. So I need to wrap this up, don't I? So the percentage of values that determine the data type, 95, we'll just leave that alone. I'm going to click OK. Okay, so there's the SPSS data. So it includes an ID code for each individual respondent has their own ID number. There's the bid amount, 5, 20, 35, and 50. There's the target variable. That's for someone who it's equal to 1 if they try to catch red drum, equal to 0 if they don't. Yes, 1 is whether they are willing to pay. They say they would make the donation of $5. And this second person would not make a donation of $20. If the person says they would make the donation to the first question, we ask them how certain they are, and here are the numbers from 1 to 10. So you see if they say 7 and above, yes 2 is still coded as a 1. 9, 9, 5, if they say 5, that's below the 7 cutoff, and so they are recoded as a 0. So we say that The yes to variable purges out any hypothetical bias that might be present. And it provides it's going to provide a more conservative estimate of willingness to pay. Okay, so first thing I'm going to do with my data set is save it. And I'll just save it to the desktop, give it the same name as the Excel data set. Okay, so we want to create frequencies of the yes responses at each of the bit amounts. So to do that, go to the Analyze tab and click on Descriptive Statistics and then crosstabs. Okay, before we do that, let's look at the frequencies. Okay, we want to analyze the bid. Let's first analyze just the bid and yes one. So click the right arrow and it puts those variables in my variable box. And if I click OK, then I get two frequency tables for each of these variables separately. Okay, so here's 317 responses, and this frequency tells me how many of the survey respondents received each of those bid amounts, 5, 20, 35, 50. And then the percentages of those. And it looks like those numbers were fairly randomly assigned. They range from 23% to 27%. And the yes one frequency analysis just tells me the percentage of people who would pay the bid amount. So if yes one is equal to 1, then 46% are willing to pay the bid amount. Okay, so that's good information to know, but it's not what we need for the terminal estimate of willingness to pay. Okay, so for that, click on Analyze, and then Descriptive Statistics, and crosstabs. Okay, so now we have a row and a column box, and if you click on, we want to put the bid amount into the row, and the survey response into the column. And if you click on OK, then that will give us the yes responses, either 0 or 1, for each of the bid amounts. Okay. So with this table, we could calculate the percentage of people who say yes at each of the bid amounts. So that would be, for $5, the percentage would be equal to 58 divided by 86. For $20, it'd be equal to 35 divided by 74, and on down the table. Okay, to avoid doing that by hand, we could go back to Analyze, click on Descriptive Statistics, and cross tabs again, and there's the variables that we previously put into the row and column boxes. And now if you click on Cells, and if you ask SPSS to compute the row percentages for you, then you're not going to have to make that calculation. So click Continue and OK. And this percentage underneath the yes responses at each of the bid amounts is the number that you need for the terminal estimator. So here we see that at a bid amount of $5, 67% are willing to pay that. If the bid is $20, 47% are willing to pay that. 35 falls to 34%. And at $50, it's, again, 34%. So the percentage yes values flattens out at the two highest bid amounts. Okay, so if you have a project where you are asked to correct for hypothetical bias, then you'll be given a data set that has a yes one and a yes one variable in it, or variables that are defined similarly. So to estimate the Turnbull willingness to pay with the second yes variable, you just need to get rid of yes one in your column box and put yes two in the column box and click OK. And you get the same sort of crosstab with the percentages, row percentages calculated for you. So with this more conservative demand curve, the people who are willing to pay at each of the bid amounts goes from 59% down to 25%. And because of that recoding based on the certainty variable, these percentages will always be below the percentages for the yes one calculation. Okay, let's go back to the data. Okay, now some other students will be asked to do a scope test or some other sort of comparison of their willingness to pay data. And the data set that you'll receive will have a column that will include a variable like a target that's a 0, 1 variable. Okay, most of these data sets will be a scope test where we try to answer the question is more better. So is willingness to pay for a larger scope of the policy higher than willingness to pay for a smaller scope? Okay, so to generate the frequencies for that comparison, if you go back to Analyze, click on Descriptive Statistics and crosstabs. Okay, and let's do this for yes one. Okay, if it's the target or scope or whatever variable that you're making the comparison for is in your variable list, and click on that and include that in this layer box. And this, click on the right hand arrow and let's check the cells, and yeah, we want the row statistics or the row percentages, and then click continue and then click OK. Okay, so here crosstab is for the bid times yes one, and now yes one times the target. Okay, so the output that you'll receive now includes a distinction for whether target is equal to 0. So these are people who do not try to catch red drum when they go fishing, or target equals 1, and this is people who do try to catch red drum when they go fishing. Okay, so you see that as the bid goes from 5 to 50 for people who do not target red drum, the amount that are willing to pay that bid amount goes from 42% down to 12%, 13% at $35, and 19% at $50. Okay, so it actually rises when the bid goes from 35 to 50, which is a violation of economic theory. That is, the cost rises, someone's expected to do less of whatever that activity is. But if you look at the sample sizes for these bid amounts, they're all pretty small. So in your Stats 1 course, you're told that a large sample is greater than 30. And so we don't want to make too much of the fact that the bid amount rises from 35 to 50. So for people who do target red drum, the bid amounts, as the bid amounts rise from 5 to 50, the people who say they're willing to pay that amount falls from 78% at $5 down to 39% at $50. And then they give you the combined amounts, and you see that if, well, the amount of people willing to pay from $5 to $50 falls from 67% to 34%, which is the result that we found on our first crosstab. And that, I think that includes everything that you'll need to be able to do with SPSS for your research project.